Now we're going to learn about the circular linked list. We've looked at the singly, we've looked at the doubly. Now we're going to learn about the circular linked list. In singly and doubly linked list, the last node always points to none. But in circular linked list, the last node points back to the first node or to the head, forming a loop. There is no none at the end, and because we have a loop-like structure, if you try to loop a circular linked list, you're going to end up in an indefinite loop. So you can build a circular linked list using singly or doubly linked list, but we're going to do an implementation of the circular linked list using the singly. So let's go ahead and implement a circular linked list. And you can use the singly or doubly to implement a circular linked list. The only thing that makes it a circular linked list is that the last node points to the head, forming a loop. And we're going to be making use of the singly in this implementation. And we're going to start by creating our node class. So we have class node. And we'll have our constructor. And here we're going to have our data, and we have self.data is equal to data, and we'll have self.next is equal to none. Now let's go ahead and implement the linked list. And for this, we're going to have class circular linked list. We'll have our constructor, def init. And here we're going to assign self.head to be equal to none. Now let's see how we can traverse the list. Later on, we're going to perform some insertions. And while we're traversing, we want to display the data in our linked list. So we have def display. We have self. And before we go ahead and traverse the list, we need to confirm whether we are dealing with an empty list. If we are dealing with an empty list, we'll simply do nothing. So we have if not self dot head, then we'll simply return. We'll do nothing because it is an empty list. But in a situation whereby the list is not empty, we're going to traverse. We're going to start from the beginning. So we'll have current is equal to self.head. Because this is a circular linked list, there is no end. It is a circular stuff. What we're going to do is we're going to loop the list and get to the node that is pointing to the head. To do this, we'll have while true, and we have print. We'll have current.data. We'll have an arrow. Then we'll use our end argument and we'll provide a space and close the parenthesis. Now we're going to move to the next node. So we'll have current is equal to current.next. Then we'll check whether the next node is the head. If it is the head, we'll break the loop. So we'll have if current is equal to self.head, then we'll break the loop. So this is how we can traverse and display the content of our linked list. So let's go ahead and implement methods for insertion. And we're going to be starting with inserting at the beginning. So we'll have insert at beginning. We'll have self and we have the data that we want to insert. And we'll start by creating our node. So we'll have new node is equal to node. Then we'll provide the data. Next, we're going to confirm whether we are dealing with an empty list. If we're dealing with an empty list, we're going to be assigning the next attribute of the new node to point to the new node. And we're going to be making the new node the head. So we'll have if not self dot head, we'll have new node dot next is equal to new node. And we'll have self dot head is equal to new node. Then we'll return. But in a situation whereby we're dealing with a non-empty list, we're going to get to the node pointing to the head. That is, we're going to get to the last node, which is the node pointing to the head. When we get to that point, we're going to assign the next attribute of the last node to point to the new node. We're also going to make the new node the head, and we're going to assign the next attribute of the new node to point to the current head. And to do this, we're going to be starting from the beginning. So we'll have current is equal to self dot head. So we'll have while current dot next is not equal to self dot head. So we'll have current is equal to current dot next. This is going to take us to the last node, which is the node pointing to the head. But first, we're going to assign the next attribute of the new node to the current head. So we'll have new node dot next is equal to self dot head. And we're going to assign the next attribute of the current head to point to the new node. So we'll have current dot next is equal to new node. Now we're going to make the new node the head, and we'll have self dot head is equal to new node. So this is how we can insert at the beginning. So let's go ahead and try this out, and we'll have CL is equal to circular linked list. And we insert at the beginning, so we'll have CL dot insert at beginning, and we'll put the data. So let's put 100, and we'll display. So we'll have CL dot display, and we'll run it. You can see we have 100. So let's add more data. We're going to copy this and paste below. So let me change it to 200 and run it. So you can see 200. We can insert again. And here we're going to have 300, and we'll run it. We'll have 300. So this is how we can insert at the beginning. Next, we're going to implement a method for inserting at the end. So we'll have def insert at end. We'll have self, we have data. And we're going to start by creating our node. So we'll have new node is equal to node. We'll have data. And we're going to check whether we're dealing with an empty list. And if we're dealing with an empty list, we'll simply use the logic we used in the insert at the beginning. So we'll have if not self dot head. We'll have new node dot next is equal to new node, and we'll make the new node the head. So we'll have self dot head is equal to new node, and we'll return. But if we're not dealing with an empty list, we're going to move all the way to the end of the list. So we'll have current is equal to self dot head, and while current dot next is not equal to self dot head, and we'll have current is equal to current dot next. This is going to take us to the last node, and when we get to the last node, we're going to be assigning the next attribute of the last node to the new node. So I have current dot next is equal to new node, and we'll assign the next attribute of the new node to the head. So we'll have new node dot next is equal to self dot head. So let's try it out. And currently we have 100 in our last node, and we're going to have cl dot insert at end. We'll have 400 and we'll run it. So you can see we were able to insert at the end. So let's try another one. We'll have cl.insert at end, and we'll have 500 and we'll run it. So we'll have 500 at the end. So this is how we can insert at the beginning and the end. Now let's look at how we can perform deletions. So now we're going to be implementing a method for deleting from the beginning. So we'll have df delete at beginning. We'll have self and we'll have our colon. But first we need to confirm whether we're dealing with an empty list. If the list is empty, we'll raise an exception. So we'll have if not self dot head raise exception. And for the message, we're going to have empty list. Then we'll close our parentheses. Then in a situation whereby we'll have a single item list, which means that that node is also the head, what we will do is to simply assign the head to none, and this way we'll delete the node. And to handle this, we'll have if self.head.next is equal to self.head, which means it's a single item list. We'll have self.head is equal to none, and we'll return. But in a situation whereby our list is not empty and it's not a single item list, we're going to move all the way to the end of the list. So we'll have current is equal to self.head, and we'll have while current.next is not equal to self.head. Now we'll have current is equal to current.next. This is going to take us to the last node, which is the node pointing to the head. And when we get to that node, we're going to assign the next attribute of the current node to the node after the head. So have current.next is equal to self.head.next. Then we're going to make the node after the current head to become the head. So have self.head is equal to self.head.next. This way we'll delete at the beginning. So let's go ahead and try this out. And currently we have 300 at the beginning. So let's see cl.delete at beginning. Let's run it. So we've deleted 300. So let's go ahead and delete 200. I'm going to copy this and paste it below and run it. 200 has been deleted. So this is how we delete at the beginning. So let's see how we can delete at the end. To delete at end, we're going to have def delete at end. We'll have self, close our parentheses and our colon. Just like deleting at the beginning, we need to confirm whether we're dealing with an empty list. So we'll have if not self.head, then we'll raise an exception. So we'll have raise exception. And for the message, we'll have empty list. Then in a situation whereby we'll have a single item list, we're going to have if self.head.next is equal to self.head. Then we'll have self.head is equal to none, and we'll return. Then in a situation whereby it is not a single item list and it's not an empty list, we're going to start from the beginning. So we'll have current is equal to self.head. Then we have while current.next is not equal to self.head. To delete at the end, we need to keep track of the last node, which is the one pointing to the head, and the node before the last one. So we're going to be pointing the next attribute of the node before the last one to the current head or to the head of the list. So we're going to be using previous to keep track of the node before the next one. To do this, we're going to have previous is equal to current, and current becomes current.next. So that when we get to the very end of the list, the previous is going to be the node before the last node. So now we're going to be pointing the next attribute of the node before the last one to the head. So we'll have previous.next is equal to self.head. So this is how we can delete at the end. So let's go ahead and try this out, and I'm going to be deleting this and we'll run it. Currently we have 500 at the end. So let's have cl.delete at end and run it. So we've deleted 500. Let's delete 400 and we'll paste it here, and this is going to remove 400. So this is how we can delete at the end. There are other methods you can implement in this circular linked list, like getting the length or searching for values, but you can use the same logic that we used in the singly to achieve this. The only thing you have to keep at the back of your mind is that the last node points back to the head and not to none. And this brings us to the end of linked list. In our next lesson, we'll learn about stacks and queues.